Compounding interest and the number E. $100 is invested at 12% for 1 year. Now this is simple interest, but we could also use the compounding interest formula. So here's the compounding interest formula. P is your principal that you're investing, R is the interest rate, N is the number of times you're compounding it, and T is how long you're compounding it in years. So if you're compounding it semi-annually, N is 2. Quarterly, N is 4, monthly, and daily. Since we are not compounding it at all, then N is 1. So we plug in P, R, converted to a decimal, N is 1 and T is 1. So plug that into your calculator and see what you get. We find out that after 1 year, you now have $112 in the bank. That is the amount you have after applying the interest. Next, we're going to compound the interest semi-annually. So if it's semi-annually, then N equals 2. So $100, 12%. If you're compounding it semi-annually, you're going to stop in 6 months, calculate the interest, put the interest into the account, and then let it go the rest of the year. So at 6 months, you're not going to earn 12%, you're going to earn 6%. And then the second half of the year, another 6%. Hopefully you can see that at the end of the year, you will have more money. During the second half of the year, there was more money in the account to calculate interest on. So R is 12 divided by 2, time is 1, and the number of times of compounding is 2. These actually got switched. So plug it into your calculator and see what you get. So this time, after a year, when you stop in the middle to calculate the interest and throw that money into the account, you have $112.36. Next, we're going to compound it quarterly. We're going to take the 12%, divide it by 4, but then we're going to take the time and multiply it by 4. So calculate this and see what you get. So if you plug this into the calculator, you should get $112.55. So in this case, we're compounding it quarterly. We're going to stop every quarter, compound the interest, put that money into the account. Now we're going to compound it monthly. So we're going to take the interest rate, divide it by 12, take the 1 year and multiply it by 12. Put that into your calculator and see what you get. You should get $112.68. Now we're going to compound it daily. Plug that into your calculator. $112.74. Now, money grows by compounding it. Other things in nature also grow, but they don't grow once a day. They don't grow once a month. They grow continuously. So let's use the formula for compounding interest continuously and see how that number compares to what we have. So PERT, the formula for compounding interest continuously is PERT, P times E to the RT. P is 100, E, R is 0.12, and T is 1. E is 2.718, which is rounded, but it's better if you use the E button on your calculator. Plug that into your calculator and see what you get. You should get $112.75. We can see that compounding it continuously is just a little bit more than compounding it daily. In nature, this is the type of compounding that you see. The number E is a famous irrational number. You learned in junior high about the number pi. Pi is irrational. E is also irrational. And it is one of the most important numbers in mathematics. The first few digits are all those digits. It is often called Euler's number after Leonhard Euler. Now, how was E discovered? We're not going to go into that at this time. It is a very important number and it is used to calculate something that is compounded continuously.